let me just kick off from where we left off last, right? So, this idea of integration, the whole idea is to find areas under curves. That's the question we were trying to answer. And I didn't address that because I didn't get time to do it in the last one, but now we're going to do that. The concept is always the same, right? We can always use our same techniques that we've used with integration in the past to find areas under a curve and apply them to trigonometric ratios. But here's my pro tip to you. When you're finding areas under a curve, especially with trigonometric functions, you really need to graph them. Okay, this is where graphing them is going to be, your graphing skills are going to be really important because you need to be familiar with what each of these functions look like. Why do you think it might be important to do a sketch before you actually try and answer?
To visualize it.
To visualize it? And it's always good to visualize things, but particularly with
finding where the areas are as well.
Particularly with integration. What do you mean, Carl?
Like, because there's more than one area enclosed by the curve.
Okay, so for example, if I drew the sine curve, I know it looks like this.
There's two areas, one on top of the axis.
Why is it important? That's a really good point, Callum. It's really important to visualize these areas, but for integration, why is it important that I actually visualize where the areas are? Yeah. Natasha, say it again? Yeah, right, because you know that this one, if you evaluated the integral, it would be positive.
And then the next one would be negative. It would just cancel out.
This one would be negative. It would cancel out. So, if I looked at this question and I didn't graph it, I just saw, okay, integral of sine of x, and it says between the x-axis, the y-axis, and the line x equals to 2 pi, so like that. And I just did the integral straight from 0 to 2 pi. What would be the problem with that?
You got pi.
Sorry?
You get 0.
Good, right, because these areas are the same, right? The sine curve is symmetrical.
Yeah.
It would just give you 0, and that's obviously not the answer to this case. So, we have a few different techniques here. Okay. What do you think would be one idea I could do in order to find the actual areas enclosed here?
Calculate both separately?
Yeah, we could calculate both. Why don't we split them up, right? So, instead of doing from 0 to 2 pi, let's go from 0 to pi.
And then add the
Pi
two
to
at the
2
end.
pi.
And then that's that area here. But I also have this area
You kind of
here.
have a negative area. Why don't you just flip the sign?
And that's exactly what I'm going to do. I'm going to write that as the absolute value of the integral from integral from pi to 2 pi. Okay. So can you see, by putting the absolute value there, whatever I'm going to get here, I'm just going to make it positive because I'm looking for an area. I know that if I just evaluate the integral, it would be negative, but I'm looking for a positive value because I'm looking for area. Okay. And then we can just do that as per normal, right? What's the integral of sine x again?
Minus.
Yeah, minus cos x. So after I apply my integral, I make sure that I put in my square brackets, right? I've got my bounds here, I don't want to forget them. So 0 to pi. This one, when you're writing the absolute value, you just want to keep it there, right? Because you only apply it at the end of your calculation, okay? At the very end of your calculation, then you'll find the positive version of it, okay? So I'm going from, again, same integral, so negative cos x from pi to 2 pi. Okay, leave that there. Now, with these ones, right, with our exact values, you can either memorize those values or you can draw the tree graph to remember what they look like. But I'm just going to substitute the values before I even do that, right? So I've got negative cos pi minus, be careful with all these minuses going on here, minus cos 0 plus, again, absolute value here. You've got, negative cos 2 pi minus cos pi. So a lot of negatives going on. You just want to be careful with these brackets. A sketch is not only useful though for actually visualizing the integral, it can also be useful for finding the exact values, right? If I just draw cos really quickly. Yeah, okay. It can also help you visualize what the exact value would actually be, right? When cos is at pi, what's the value? It's negative 1, right? But here you've got negative of that, which is well, that's just going to be 1 minus, what's cos of 0?
1.
Yeah, right. When your x value is 0, your y value is just 1. So here I've got 1 minus 1, which is just 1 plus 1. Right.
2.
So negative 1, which is just 2. I'll add it at the end later. What's negative cos 2 pi? What's that going to be?
1. It'll be 0.
So you've got at cos of 2 pi, what is it normally? It's 1. But then you want the negative version of that, right? So you've got negative 1 minus, and again, cos of pi, I already know what that is. That's going to be, what?
0.
1. So again,
Minus 1.
so I've got negative cos pi.
Minus 1. Positive 1.
So cos pi is just negative 1, but then I've got a negative that, so that's 1.
And then there's a minus out.
Yeah, that makes sense. Okay, are we clear what just happened? Or are we a bit?
Yeah.
So there's a lot of negatives going on there. So
There's a lot.
not the best one to start with, my bad. So this is why it's really important. Now we can just put it all together, right? We've got here 1 plus 1, which is just 2, and this, what's this? This is minus 1, which is going to be negative 2. But what do I have on the outside here?
Absolutely.
Yeah, so that's actually going to be a positive
So it's
2.
4.
This is 2 plus 2, which is
is correct because they both should
Four.
be equal, right?
units squared. Now, Nathan, say that again, sorry.
It's correct because both areas should be equal.
Okay, so you're saying that this one is 2, and this one is also 2, right? There's actually another way you could have done this one. Can anyone
work out one.
Yeah. What you can notice is, if you are very comfortable and confident with what these functions actually look like, you know that these areas should be the same, you could have just done the area from 0 to pi,
And
right?
did it.
Yeah, and then multiplied it by 2. Because that way, you actually get the same answer. Now, that doesn't always work. You have to be confident about when you can actually do that. The safest way, again, is to always split it up if your areas are going above or below the axis. Any questions about that?